Hello everyone and assalamu alaikum. This video is on the second part of the GCSE Edexcel Maths 2018 May non-calculator paper. I have a bit of a cold, so apologies for my voice. Right, we've done the first 9 questions in the previous video. Try and do the rest in this one. If I can't manage to finish all of them in this one, I'll upload another one with the remaining questions. So let's get started. The table, question number 10 says the table gives some information about the heights of 80 girls. The least height is 133 centimeters. So I'm gonna go ahead and mark 133, or draw the line for 133 centimeters for my stem and leaf diagram. You can see 133 would be roughly about here, so I draw a line like that. Okay, the greatest height is 170 centimeters. I've just done that, so I'm going to tick it off. Greatest height is 170, so I'll draw a line like so, a vertical line on 170 over there. Okay, done that. The lower quartile is 145, so at 145 draw a line like so. Upper quartile is 157, so at 157 draw a line like so, and the median is at 151. Let me tick off 157 and the median 151. Right, so I'm gonna draw another vertical line there, and now I'm gonna join these up like so, and then another line from here to there, and one from here to there. Right, so if you find these kind of questions difficult, that's your lowest value, that's your highest value, that's your lower quartile, that's your upper quartile, and that's your median. And that's how we draw a box plot. Alright, let's move on to the next question. It says, this 10 part B, work out an estimate for the number of these girls with a height between 133 centimeters and 157 centimeters. So let's go back to our diagram, and we're looking for people with a height between 133 centimeters and 157. That's 157. That's 157. So we're looking for people in this kind of region. Okay, so the upper quartile, which is this bit, so the distance from the upper quartile to the highest value is your top 25%. So the distance from 133 to 157 is your bottom 75%. So we're finding we've got 80 people. So I would do find 75% of 80. That's 75 over 100 times 80. Now I can divide these two by 25. Divided by 25, divided by 25. That's the same as 304 times 80. So I'm gonna carry on down here. 80 divided by 4 is 20, and 20 times 3 is 60. So an estimate for the number of people with a height from 133 to 157, that's going to be roughly about 60 people, because that's 75% of the data. Okay, how do I know that? If I go back here, so this distance this distance is the top 25, this is the bottom 25, this is the middle 50. So if I do the bottom 25 plus the middle 50, that gives me 75%. So 75% of 80 should have occurred by then. That's 60. Alright, next question, question number 11. A and B are points on a circle with center O. BC is a tangent to the circle. Angle AOC is a straight line. Very good. Angle ABO is X degrees. They have not drawn angle ABO. So the first thing I want to do is join that up. So that's supposed to be ABO. Let's redo the angle. Okay, and I need my pen. This is X degrees. Since this is a radius and this is a radius, that's going to be an isosceles triangle, so angle OAB will also be X degrees. Find the size of angle ACB in terms of X. Okay, let's get started. Right, give your answer in its simplest form and give reasons. So I'm going to start here on the right. So I'm going to start off with my first bit of reasoning. Angle OAB is equal to X degrees, and that's angle OAB. The reason for that is OA and OB are radii, and base angles OA and OB are radii. Radii is the plural of a radius, so one radius, many radii. And base angles of an isosceles triangle are equal. Okay, now I can see this angle here is 90 degrees. So angle OBC is 90 degrees. And the reason for that is, you see, BC is a tangent and OB is a radius. And there's a circle theorem that states that radius and tangent meet at 90 degrees. Right. Okay, so if you look at the bigger triangle now, triangle ABC, this angle here, the whole angle will be 90 plus X. 90 degrees from angle OBC and X from angle ABO. So we can say in triangle ABC, x, which is angle CAB. Angle CAB is this one, CAB. So I'm looking at this x plus 90 plus x plus angle ACB equals 180 degrees. Write down the reason over here. Angles in a triangle add up to 180 degrees. Okay, I'll try and speed up this process. So these two are like terms, so that's gonna give me 2x plus 90 plus, that's 90 degrees, angle ACB equals 180 degrees. So what I could do is I could subtract 90 both sides. Minus 90 minus 90. So that would leave me with 2x plus angle ACB is equal to 90 degrees. And then to get angle ACB on its own, I'm going to subtract 2x both sides. So then I get angle ACB is 90 degrees minus 2x. And that's that. So find the size of angle ACB. That's 90 minus 2x. Okay. Have I missed out any reasons? Let's see. Nope. Let's move on to the next question. Prove that the square of an odd number is always one more than a multiple of 4. Okay. Let's start off this question. Let n be an integer, let's say a positive integer, right? So n could be any value, so 2n is even because every multiple of 2 is even. Prove that the square of an odd number. Alright, and 2n plus 1, so if you add 1 to an even number, you get an odd number. Or if you add an odd number to an even number, you always get an odd number. Right, let's square this odd number. So 2n plus 1 whole squared, that'll be the same as saying 2n plus 1 times 2n plus 1. Let's expand the bracket. So 2n times 2n is going to give me 4n squared, and I'm going to do 2n times 1 plus 2n, and I'm going to do 1 times 2n, that's another 2n, and I'm going to do 1 times 1 plus 1. So that'll be 4n squared. You can add the two 2n's to give you 4n plus 1. Now you see these two are multiples of 4, so I can just quickly factorize that by saying 4n bracket n plus 1 plus 1, and there you go. So it's one more than a multiple of 4, because 4n is a multiple of 4, and I'm adding 1 to a multiple of 4. 4n times n plus 1 is a multiple of 4, and I'm adding 1 to it. Right, next question. Question 13. Square root 5 times root 8 plus 18. Root 18 can be written in the form a root 10. Okay, so let's get started with this question where a is an integer. Sorry, find the value of a. So let's write square root of 5 times square root of 8 plus square root of 18. The first thing I'm going to do is expand the brackets. So square root of 5 times square root of 8 is square root of 40. So I've multiplied these two. Then I'm going to multiply these two. So square root of 5 plus square root of 18 is square root of 90. Okay, now it wants this in the form a root 10. So I need to write these as multiples of 10. So 4 times 10 is 40 and 9 times 10 is 90. And I can say, hang on, square root of 4 is 2, right? So I can write it as 2 root 10. And square root of 9 is 3. So I can write this as 3 root 10. And I can add these two surds to give me 5 root 10. So the value of a is 5. Okay, that is done. Let's move on to question 14. Y is inversely proportional to d squared. So I can write that down as this. So this symbol here is alpha, Greek letter alpha, is the symbol used to show something is proportional. If it's directly proportional, I would have written y alpha d squared, but because it's inversely proportional, I'll write y alpha 1 over d squared. Okay, so then I can form a sort of relationship. So y is equal to a constant divided by d squared, and I need to find the value of that constant. It says when d is equal to 10, y is equal to 4. So I'm going to substitute those values. Y will be 4. That's going to be k divided by, and d was 10, right? So 10 squared. And that would give me, I'm going to carry on the right. So 4 is equal to k over 100. 10 squared is 100. And in order to get to k on its own, I'm going to multiply both sides by 100. So k, that constant, is 400. So my new formula will be y equals 400 divided by d squared. Done that? Okay. It says d is directly proportional to x squared. Okay, that's another bit. I'm going to do that in a different color. So d is equal to, wait, let me write this down. D is directly proportional to x squared. So d is alpha x squared, which is, d is a constant times x squared, another constant. When d is equal to 24, x is 2, so k times 2 squared. So k will be k times 4, that's a k by the way, is equal to 24. So I divide both sides by 4. So k is equal to 6. So my relationship over here, or the formula for d, is d equals 6x squared. Find a formula for y in terms of x. So the last bit I'm going to do it in a different color. I'm going to split this. So I know y is equal to 400 divided by d squared. but I know that d is 6x squared, so y is equal to 400 divided by 6x squared, the whole thing squared. So that gives me y is equal to 400 divided by 36. So I square the 6 squared is 36, and that'll be squaring x squared would give me x to the power 4. 436 both come in the 4 times table, so I can write it as 100. 400 divided by 4 is 100, and 36 divided by 4 is 9. So that's what I get for my answer. Y equals 100 over 9 x to the power 4. Okay, let's move on. Right, so this question, factorize a squared minus b squared. That's the difference of two squares. So I find the square root of a squared, that's a. Find the square root of b squared, which is b. So I'll have a plus b times a minus b. That's how we factorize the difference of two squares. It says hence or otherwise. That's my answer going to be over there. Simplify x squared plus 4 squared. So that's like my a squared minus my b squared x squared minus 2. So my a in this case would be x squared plus 4 plus my b is x squared minus 2, and then my a would be again x squared plus 4 minus this times my b be x squared minus 2. Okay, let's try and simplify this. So the like terms here are 2x squared, and x squared is 2x squared, and 4 minus 2 is 2. That's going to be my first bracket. In the second bracket, there's some work to do. So I'll have x squared plus 4 minus x squared plus 2. So the 2x squared will cancel out, and 4 plus 2 is 6. So I can write this as 2x squared plus 2 times 6. Okay, let's move on to the next question. There are only red counters, blue counters, and purple counters in a bag. The ratio of the number of red counters to the blue counters, so there's red to blue, is 3 to 17. That's 20 pots. Sam takes a random counter from the bag. The probability that the counter is purple is 0.2. Okay, let's stop there. Right, that's a lot of information and very important. So imagine a little rectangle. Yeah, and this represents the whole probability. So if this probability is 0.2 of purple, then red or blue, the remaining probability would be 0.8. 0.8 is going to be split into 20 parts. So I'm going to do 0.8 divided by 20. So that would give me, if I do 0.8 divided by 2 is 0.4, and 0.4 divided by 10, that will be 0.04. So 0.8 divided by 20 is 0.04. Alright, now the red parts is 3 times 0.04, which is 0.12, and blue is 17 parts times 0.04, which would be 40 and 28, so 0.68. Okay, work out the probability that Sam takes a red counter. 0.12. Okay, we'll move on to the next question. Simplify fully 3x squared minus 8x minus 3. I'm going to try and factorize these, and I'll simplify it. So let's try factorizing. Whenever I get a question like this, my brain goes straight away factorize. So the numerator is 3x squared minus 8x minus 3, because this is one algebraic fraction. That's why I'm going to factorize it. So I factorize it in this way. So I write it in the form ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is the y-intercept. Then I do a times c is 3 times minus 3, which is minus 9. I need to find two numbers that multiply to give you minus 9, and these same two numbers add to give you minus 8. So I can get the numbers minus 9 plus minus 9 and 1. So minus 9 times 1 is minus 9, and minus 9 plus 1 is minus 8. So I'm going to rewrite my original numerator expression, I should say. Okay, I'm going to split the middle term into the two numbers minus 9 and 1. Plus x, I could even write as 1x. And then I'm going to factorize these two and these two. So the highest common factor in the first is 3x, and the first bracket would be x minus 3, and in the second one it's 1, and it's x minus 3. Can you see the two brackets are the same? That's an indication that I've done this question correctly. So I'll have x minus 3 times 3x plus 1. That's my numerator done. I'm going to do my denominator in the middle. So 2x squared minus 6x, and just do a normal factorization here. 2x is the highest common factor, that's x minus 3. Okay, so I'm going to do the final bit in green. So my numerator can be written as x minus 3 times 3x plus 1 in the factorized form, and the denominator in the factorized form was 2x times x minus 3. What I could do is cancel out now the two x minus 3's with each other. I can only do this after factorizing, so that would give me 3x plus 1 over 2x, and that's my simplified form. Remember, when it's one fraction, it's not two different fractions, it's just one fraction. In order to simplify, you need to factorize in most cases. Let's move on. Here is the graph of y equals sine x for minus 180 to 180. On the grid, sketch the graph of y equals sine x minus 2. So the sine x minus 2 is outside the brackets, so I'm gonna, this is a translation by the the column vector 0 minus 2. What I mean by that is all the points are gonna come 2 down. So I'm gonna find the important points, which is I'm gonna start off with this one here, 0 0. It's gonna move down 2 places, so minus 2, 0 minus 2. 91 would move to 90 minus 1, because 1 minus 2 is minus 1. That would be down here. So I'm shifting everything 2 places down. 1, 2, and 1, 2. And whoa. Let me retry that. My drawing skills are not the best today, and there we go. So everything's moved sort of down 2. Alright, and that's question 18 done. The point P has coordinates 3, 4. Q has the coordinates A, B. Don't know what A, B are. A line perpendicular to PQ is given by the equation 3x plus 2y equals 7. Right, I'm going to stop there. I'm going to rearrange this. So 3x plus 2y equals 7. I need to try and find the gradient of this line. So I'm going to subtract 3x both sides. So I end up with 2y is equal to minus 3x plus 7. Then I divide both sides by 2. So y is equal to minus 3 over 2x, sorry, minus 3x plus 7 over 2, okay? So my gradient for this particular line, I'm going to call it M1, is minus 3 over 2. Since it is perpendicular to the line PQ, the gradient of the line PQ, I'm going to call it M2, is going to be the negative reciprocal of minus 3 over 2. So that, to do that, I'm going to do minus 3 over 2 to the power minus 1 multiplied by minus 1. So to get rid of the power minus 1, I flip the fraction over. 2 over minus 3, and when I multiply it by minus 1, it becomes minus 2 over minus 3, which is 2 over 3. Okay, so I have got my gradient for the line PQ. So for PQ, I know that the gradient is 2 over 3. The coordinates of P are 3, 4, and the coordinates of Q are A and B. Right, where I need a different color. I'm going to call this x1, y1, and x2, y2. So in order to find the gradient, I'm going to call this gradient M2 because I'm dealing with the gradient of PQ. If you do the vertical distance, which is y2 minus y1, divided by the horizontal distance, x2 minus x1. So we know the gradient is 2 over 3, and y2 will be b, minus y1 will be 4 over x2, which is a, minus x1, oh I forgot x1 there, which is 3. Okay, at this point I'm going to cross multiply. So because I've got one fraction on the left and only one fraction on the right, I can cross multiply. So that'll be 2 times a minus 3 is equal to 3 times b minus 4. I'm going to carry it on over here. So 2a minus 6, when I expand that, is equal to 3b minus 12. So it says find an expression for b in terms of a. So I need to make b the subject. So I need to add 12 both sides. That's 2a plus 6 is equal to 3b. Now I divide both sides by 3. So b equals 2a plus 6 over 3. Alright, how many more questions do we have? Question number 20. I think this is the last question. N is an integer such that 3n plus 2 is less than and equal to 14, and 6n over n squared plus 5 is greater than 1. So find all the possible values of n. So I'm going to start by trying to solve each individual inequality. 3n plus 2, so I'm going to start off with the linear one because it's a bit easier. It's less than and equal to 14, so it's very similar to equations. Subtract 2 both sides, so 3n is less than or equal to 12, and then divide both sides by 3. So my first inequality is n is less than or equal to 4. Alright, the next bit, the quadratic one, I'm going to do it in a different color, and this is a bit complex. So it's 6n over n squared plus 5 is greater than 1. First thing, I multiply both sides by n squared plus 5. Multiply this also by n squared plus 5. So over here these two n squared plus 5s will cancel out on the left hand side, leaving you with 6n is greater than 1 times n squared plus 5 is n squared plus 5. Then on minus 6n both sides, so this would be 0 is greater than n squared plus 5 minus 6n. I'm going to factorize this just like before. So two numbers that multiply to give you minus 6, with the same numbers add to give you 5. So those numbers are going to be n squared. The numbers are going to be 6 and minus 1. So n squared plus, oh sorry, my mistake. So let me rewrite this. I'm going to rearrange this as n squared minus 6n plus 5. Okay, two numbers that multiply to give you 5, not minus 6. Two numbers that multiply to give you 5, and the same two numbers add to give you minus 6. So my two numbers are going to be minus 1 and minus 5. So minus 1 plus minus 5 is minus 6, and minus 1 times minus 5 is plus 5. So I'm going to split this into the two numbers, minus 5n minus 1n plus 5, and then I'll carry on factorizing it. N squared, oh sorry, I factorize these two, and then I factorize those two. So this will be n brackets n minus 5, that'll be minus 1 brackets n minus 5, and I'll carry on this side. So n minus 5 times n minus 1 is greater than 0. So what I'm going to do is, in order to finish this inequality, I need to sketch the graph for this quadratic equation. So what I would do is I would imagine n minus 5 times n minus 1 is equal to 0. So I would get the answers n is equal, either n minus 5 equals 0 or n minus 1 equals 0. And to get this, to solve this, I'd add 5 both sides, so n is equal to 5, and to find this value I'd add 1 both sides, so n is equal to 1. Right, so my graph would be like a U-shaped graph that looks like this. Oops. So that would be 1, and that would be 5. Okay, but because the inequality says it's less than 0, I need to find the region which is below the x-axis, which is over here, right? And remember, that point was 1 and that point was 5. So to be in this yellow region over here, n has to be greater than 1, but it also has to be less than 5. So you can write it as two inequalities like this. Now the limitations from the first one, the first inequality, was n is less than or equal to 4. So n can be 4, but it has to be less than 4. It can be equal to 4 or less than 4. Here we have a limitation, n has to be greater than 1, and this limitation is n is less than 5. But this limitation already restricts n from being 5. So find all the possible values of n. An integer is a positive or negative whole number. So the values of n could possibly be, well, it has to be greater than 1, so it can be 2, it can be 3, and it can be 4. It can't be any more integers. So 2, 3 and 4 are the only values it can take. And I think that's the last question in this exam paper. So hopefully, I know I was rushed in the second part of the video, but I hope it has helped you answer the questions. If you have any questions or did not understand any of the explanations, please let me know, and I will try and elaborate when I get some time. And all the best with your exams. Hope this helps.